First, some logistics. So project two is finally wrapping up now. And you guys can finally kind of throw all of that into the trash. But Tuesday through Friday, so interviews have started. Hopefully everybody has signed up for those you were supposed to by last night. Um, and yeah, the midterm is actually going to be assigned this Friday, and it's going to be due next Tuesday. I've actually stripped it down a little. It's going to be like a timed quiz, so you can only spend like 30 minutes probably based on what I decide. It will be multiple choice, so no coding, no kind of mini project that you actually have to do. And the main thing I want to test is just some kind of common misconceptions I'm seeing related to JavaScript, like functions, React state, things like that. And I'm hoping to reinforce those a little through these questions. So it should be really low commitment, and you have multiple days to choose when you want to take out that 30 minutes. I posted this on Slack yesterday already, so this shouldn't come as a surprise. I also had listed out the high level concepts that I'm going to be covering. So in case you do want to study, you can, but I really think that if you did project two and you kind of understand the code and understand why things were working as they were, then you really don't need to study at all. And then project three is going to begin soon. So next Monday, this coming Monday, I'm basically going to assign the groups and release those on Canvas, as well as connect you with your industry mentors. Remember that the project three groups are I'm only going to be assigning those who got above a 70 average between project one and two. That's been on the syllabus since day one, so that's not changing. I will reach out to those as we're grading by Friday, in case that you were not going to be able to be assigned to project three. So I will probably email you by the end of the week. For most of you, that shouldn't be an issue. You should know based on the rubric and your submissions where you would be at. So groups are assigned next Monday, and then the group proposal is going to be due within 1 week, so April 5th. You guys are basically going to write up specs similar to what I've written in project one and two, just telling like the high level idea and how you're going to break down that work, what sort of features you're going to implement, things like that. Oh, really? The group shows on Canvas already? Okay. Whatever you see on Canvas, I'm going to delete those because I was probably just testing out the feature, but I haven't actually moved around groups how I wanted to. So ignore those. I'll delete those. That's not your group. Thanks for letting me know though. So yeah, group proposal will be due in a week, and then you're gonna meet with your industry mentor for the first time after your group proposal is due. So you'll have your initial meeting, kind of discuss the plan with them, connect with them for the first time. After that, you're gonna have 2 weeks to work on your MVP. So the very bare bones version of your app. Doesn't have to be fancy, doesn't have to have all the features, just kind of the basic things working. And then you'll have another 2 weeks to polish it, add features, do whatever, and that'll be your polished version. So that'll be due 2 weeks later, May 4th. May 4th is also the last day of this class, and that's going to be when you have final presentations where you'll basically give like a few minutes of a demo showing what your app can do. So this is how the timeline is going to look. And next class, so Friday, I will release the specs and like show you guys more details on that now. Any questions? Midterm, project three? Okay, this should be fun, guys. I'm excited to see what everybody's going to come up with. All right, you can ask questions if you think of them later, but I'm going to keep going. Oh yeah, Mervin, are all presentations happening the same day? Yes. So you're literally going to have like 5 minutes per group to like demo and answer questions. They're only going to be like 10 groups, something like that. So it should be pretty easy to fit in. Each group is going to be about 4 people. Cool. All right. So today we're going to be talking about this kind of planning phase. So if you remember this software development cycle we've talked about in the past, there's these different steps. Usually you guys have done the implementation side of things. Verification is what you did in milestone 3, like somewhat testing and all that. Design you've kind of done more or less on the fly, or it's also been enforced by like the React starter structure, things like that. Requirements, though, is something that I've always given to you. So I've kind of always provided you this doc that tells you what you need to implement, how you need to implement it, things like that. But I'm not going to give you that really for project 3 because I don't know what you're going to implement. So today's class is going to be talking about this process where we can come up with requirements. And this process is going to help us answer questions like, who is our user, or who are our users? What does the user want? So our app, our project idea is going to be solving some problem or like addressing something that we see that people want. So how do we figure out what they want? How do we implement the product? So do we need data? Do we need to persist this data? Things like that. Who's going to implement it? When we're going to deliver it? Other questions like that. So the planning phase is super important. Often in industry, the planning phase is not done right and not done often enough. 70% of like defects that you're going to see in software are actually introduced in the requirements phase. So like that first phase. And then 30% are introduced later in the actual like technical process. So if you think about just like bugs that you introduce in your code, that's actually that 30%, something that's like an implementation issue. But most of the issues actually come with planning things out wrong. So that can be really avoidable. And out of those things that are kind of from requirements issues, 5% of those are corrected like in the first phase itself, but 95% are detected later on in the project. And when you figure out those issues later on, it's too late in many senses. So the cost for fixing that is so much higher once you're already like diving deep into your implementation and things like that. Imagine that you are saying, I'm going to use Postgres for my database in your planning phase. You haven't done the proper research though. Maybe you haven't kind of considered alternatives, things like that. And then you realize once you're actually coding it up that I don't know, your framework doesn't support Postgres, so you'd have to do a lot of extra changes to connect to the database. So if that's the case, you might have to completely switch back to a new database that your framework supports. And that would require like rewriting your schema, setting up the code differently, things like that. So as you can imagine, things get way harder as you get farther into the process. So this is a chart just kind of showing like how projects pan out by industry. Successful is basically saying that like we finished what we needed to finish on time. Challenged is that the project was submitted late or it went over budget, things like that. And failure is just that like it got scrapped, didn't end up happening. You can see here like most projects end up being like late or over budget. There's a solid amount though that just end up completely failing. I'm not really caring too much about like by industry, although there's patterns there, like seeing government failing more than others. But the thing I wanted to talk about related to this is there are certain factors of whether that kind of determine whether a project's going to be successful or not. And these factors, there's been some like research kind of showing based on these cases, what is the most common reasons for them. And yeah, 24% of government failing. It is expected. They often do very strict planning that they never are able to like adapt to later on as things change. And we're going to talk about how to make sure you're adapting to the process. So yeah, if you see these factors like on the 2014 side, the top three, they are like executive management support. That means that if you have higher ups that are investing in this or funding this or kind of just supporting this, pushing for it, if they're not bought into your idea and why you're doing it, then at the slightest mishap or like issue that comes up, they are not going to care about just completely scrapping it because it's a pain for them. So you need to make sure that they're definitely bought in. User involvement, that is basically your app is trying to serve a need for the users. You can't just assume that you know what users need. So let's say that we're talking about our grocery delivery app that we were talking about in lecture 2. You can't assume exactly how they would want to do that. You need to actually go to your users and kind of involve them, talk to them, and get data from them on what they want. Otherwise, you're going to come out with a product that probably is different from what they were expecting, and that's going to lead to you're not getting a good market fit, something like that. Clear business objectives, again, just like kind of having those clear goals of what you want to set out to do. The interesting thing though is execution is at the very bottom of this. So that's like 3 points, second to last row. And that's where you're actually coming up with the code, implementing it. So that's probably one of the smallest factors of success when you compare it to the top 3, which are all related to planning. Are your stakeholders involved? Do you have clear goals? Things like that. So that's kind of the motivation for why we need to be thinking about requirements engineering more than we often do. And this is kind of a flow in itself. So we were talking about software development cycle. Just within that first phase of requirements, there are a bunch of steps that we are going to take. So there's 6 steps. I'm basically going to go through them one by one today. And this class is going to be like a lot of material. I'm just kind of going to be talking at you for a while, but please, if you have any questions slightly related, just kind of add them to break with the monotony. All right, so first step here is inception. And this is basically saying like, this is when you define what your project is, what your idea is at a very high level. So you guys are going to be doing this next week, even this week if you want to start thinking about it early. But you want to identify some need. So a business need, a market opportunity. Maybe you're seeing that there's a need that other companies are not solving kind of well enough, something like that. Obviously, for project 3, you can also just do something that you think is cool. But generally, when you're creating a product, you'll go through this. So you're going to want to do research. You're going to want to see like, okay, there's a need. Is this feasible? So is this something that we can actually implement, in the scope that we have? So kind of defining the scope of how big you want to go here, something like that. Obviously, you're not going to do some crazy like hardware project in project 3 because there's no time and there's probably not enough skills and knowledge for that side of things. And you also want to kind of determine who all your different stakeholders are. So stakeholders are going to be anybody important to this process. That can be your users. That can be people within your company. So your other engineers, your managers, things like that. Let's go back to the example from way back when in lecture 2, the grocery delivery app. Who do you guys think are possible stakeholders if we go with that idea? Buyers and wholesalers. Yeah. So the stores, similarly, Darshil said. So whoever the stores are, they need to provide the inventory on your app so that people can buy from them. And then your customers, so the actual customers who are placing the orders, you need to make sure that they're bought into the idea and that you're using them as a stakeholder. Your driver, so whoever the delivery person is that is going between your stores and your customers, so they're a key user for your app as well. What else? So those cover on a high level your user side of things. Now let's think of stakeholders in our, let's say that we're doing grocery delivery for project 3. So employees and app investors, that would be good. Let's say if we're doing, like if we're starting a company, that type of thing. Those are definitely stakeholders. Let's say for project 3, just in this next month, who would be stakeholders kind of within your company or your team type of thing? Yeah, me. So I'm an important stakeholder. I am giving you the specifications for what I want to see. I'm giving you deadlines. I'm basically saying you need to have this done in 4 weeks. I want to see an MVP in 2 weeks, things like that. So you have to satisfy me. Your partners. So your 4 people or however many engineers that you're working with, you need to know what constraints they have. Do they have certain skills? Do they have certain time constraints, things like that? How well can you work with them even? TAs, yeah, TAs. So they are also similar to me, kind of involved in the grading process, things like that. Oh, Charles, so you shouldn't be able to see the groups actually. I'm going to delete them. I was just testing out the feature on Canvas. That's not the real groups though. So next Monday, I'm going to be releasing those. Yeah, cool. So those are good stakeholders. The other one I would include is your industry mentor. So they are going to be meeting with you every week. They are going to be kind of giving you feedback based on how things are going with your project, things like that. So you do also want to satisfy them. Okay, so step 2, once we've kind of gotten that general idea, we want to come up with the more specific requirements for our software or product. So this involves what features we're going to be kind of implementing. This involves how we're going to implement it, like what are we going to use, things like that. Usually, this process, which we call elicitation, is going to be done by either like a business analyst or a UX researcher on your team. You don't actually see software engineers included as much as they should be in this process. They kind of stick to implementation oftentimes, but they should really be more involved because they have a much better idea of like feasibility, constraints that the UX researcher, somebody who's not as technical, would understand. But the goal of this process is basically, get as much information as you can on like what sort of problems you want to solve, as well as what constraints you have, things like that. And it's not easy, this process. Maybe it's hard to find the right people. Maybe the people that you do find are not giving you kind of very specific findings. And oftentimes, like things can be really hidden, the sorts of things that you might want to find. So if you're not asking the right questions, then you're not going to get back the right answers. And one other thing is like you really can't assume in general what your users need, at least in one case. So if you're not asking like enough questions, then you're basically making assumptions about things that you didn't get info on. I don't know if you guys have heard of this in the news. I hadn't earlier, but I just saw it in the slides. There was this juicer that was like super expensive and a lot of money put into this idea. But the packs of the juicers, they actually, you could just squeeze them out by hand and like get the same value out of it without needing like this crazy expensive machine that everybody was excited about. This is a good example of just a bad elicitation process and in general a bad planning process. So clearly these investors were just super excited about an idea that wasn't very well tested with users. If they had kind of asked the right questions and tested with people, then they might have realized that this machine is actually not needed. There's other ways of going about this without pouring in all this money. So this happens super often. I feel like you've probably seen all these like crazy high tech products that are not actually that valuable. You've probably also seen products where you're just like, how has this passed multiple stages of like approval and development and made it out to the market, just because it's like a shit product. So this happens a lot of times. I feel like usually the main reason is because you're not eliciting often enough and like well enough in order to understand who you're trying to go to. Oh, really? There was a Simpsons episode on it. They do predict stuff, don't they? So yeah, there's kind of two parts of elicitation. The first is we want to see what problems our software or our product is going to solve. Um, and to do that, there are two things. So your sources of information can be, first of all, your users or your customers. Those are, I think, most important when you're thinking about what you want to do. You want to make sure that you're considering them fully. There are other people though, so your engineers, those are the stakeholders again. Your lawyers. So this isn't going to be relevant in project 3, but oftentimes you need to make sure that you are properly thinking about any legal restrictions that you might run into. So imagine our grocery delivery app. Maybe there is some regulations about food safety or something. Spending too long in the delivery process when food goes bad. I don't know. You have to make sure you're considering all these things early on. If you get hit with laws later on, then you might have to scrap the entire product. Um, and there's a lot of examples of this. Think about Uber. They are dealing with so many legal restrictions related to like um, taxi commissions, things like that in cities. So this is probably going to be important for any app. You can also get info from existing systems. So see what are other products, other systems out there that are solving things, and how do they do it. That can often be a good uh, source of info. Documentation, domain experts. Yeah, there's a bunch of things. And then there's different techniques as well for getting that information. I think the most common ones are probably going to be interviews at the bottom and surveys. Um, these are kind of more structured ways for you to get insight into your users. So planning out specific questions you want to ask different groups of people. You've probably seen like focus testing or market research being done, that sort of thing. Surveys allow you to go to a broader group of people, but it's probably not going to be as in-depth of a conversation. And there's other things like brainstorming sessions just with your own groups, observing, like just kind of going into the wild and observing how people are doing things and in like a relevant place. So I don't know, going to a grocery store, observing like the inventory or like what people are buying, things like that. But yeah, in general, I think interviews are one of the most common ones. On my team, that's also what we were doing. So our product on the team I was on was working with telecom companies. They used this app we made to kind of fix their networks and things like that. So we would have our UX researchers go like every quarter to different telecom company offices, show them our product, sit with them, watch them use it, ask them planned interview questions about it, and get insight into that. And those were some of the most insightful times of product development because we didn't have to assume things about our users. We were actually getting a lot of useful information that we wouldn't have otherwise. Like maybe realizing that they use Internet Explorer actually, and our product on Internet Explorer is completely messed up, things like that. One cool thing I actually got to, because we were working with telecom companies around the world, within like the first month when I joined, I actually got to join one of these trips and go to like Brazil and Peru to talk to the telco companies there. So it's fun. It's fun. This user research thing can be really fun. But yeah, back to the interviews. there are definitely mistakes and kind of traps that you can fall into. One is not interviewing enough people or the right people. So like in my example, we went to Brazil and Peru. South American markets might function very differently from telecom companies in Asia or Africa. So you want to make sure that you have a good sample size. You also want to make sure that you're sampling from a diverse kind of set of populations based on who your users are. So you don't want to see that one person for your grocery delivery app said, I want a text-based app only. If you go with that without talking to like 4 other people and realizing that an app with a UI would be better, then again, you're going down the wrong path. Albert, when would you provide multiple choice questions versus not? So it really depends what kind of things you're trying to get out of it. But the main kind of motivation behind that idea is that you don't want to box users in basically into a few choices, because maybe what they're thinking is something completely different. By providing multiple choices, you're basically making an assumption that they're going to want one of these 4 options and not like 10 other things that you didn't think of, something like that. So I would think that multiple choice is only useful maybe once you have a lot more focus and understanding already of your users. But definitely in the earlier stages, you wouldn't want to do that. It's a good question, though. Assuming, yeah, another thing that you can't really get around is assuming that what people say is what they actually need. So there's this quote, I don't know if you guys have heard, if I had asked people what they wanted, they would have said faster horses. So this is in regards to Henry Ford, who made like mass automobiles. If people don't exactly know, or they can't envision a car and they only know like horseback and like thinking within that framework, then you may be limited by what their idea of something is. So this can be limiting, but there's always pros and cons. An example, just like specifically with interviews, you wouldn't want to say like, are you going to use this feature to do X? You would rather say, how are you going to use this feature? Again, you don't want to lead anything with, like, you don't want to ask any leading questions. The user might have not even considered something that you're asking about. So you kind of want to keep things as general as possible in this process to really get their sense of things and not bias them in any way. In general, like for project 3, you don't need to interview people or do anything like that. You're probably going to be thinking just from within their perspective of who your users are, and brainstorming about it. But yeah, if you want to, you totally can. It's just not going to be required here because of the timeline. Okay, so the interviews and surveys, that type of thing with the users, that's more about what types of problems you're going to want to solve with your product. The other side of things is going to be more about like the system, the software that you're implementing, things like that. And when we talk about system requirements, we can actually break this down into 2 types, functional and non-functional. Functional is basically saying these are requirements that define like what the system should do. And non-functional is talking about how the system should operate. So what versus how. If we look more into functional, we're basically saying like what are the inputs or the outputs, things like that. So what kind of data should the system store? If we're talking about our grocery app, does the user need to input their zip code and then get back a list of grocery stores, something like that from the system? Do we need to store some data? So do we need to store, let's say, favorited grocery stores? We might need a database for that, things like that. So this is kind of showing more functionally what we should be able to do. And then non-functionally, we're talking about how. So how should this system work? This could be a bunch of different things, such as performance. How fast should the system respond with a list of grocery stores? How fast should our delivery person be able to deliver this? If we think about design constraints, this could be, what are we using? So like, how are we going to actually build this product? Let's say that all of your engineers on your team know Python, then you're probably going to have a design constraint where you're not going to want to use like PHP in order to build your server, because that's just not what they know. So the development process, documentation, different things like that, which I've often provided in my specs too. And then there's other constraints such as when you should kind of do something by. So how is this going to be implemented time-wise or cost-wise? How many engineers are you going to use? And how long are you going to deliver something? So these are not functional. They're really talking about the implementation, the how aspect of it. So one thing I want to do now is let's take a look at my specs. 1 second. Let me just pull this up. Okay. So here is milestone 1. Do you guys, so remember, functional is what? Non-functional is how. Do you guys see examples of functional requirements here? And chat me some that you do see. Yeah, login. So we're basically saying this is what's going to happen in our system. The user is going to have an input. They need to type something in, click a button, and when they click, the system is going to show them the tic-tac-toe game. Yep, that's good. What else? Running on Slash. So we are basically saying that this is where the user can access our app. So again, this is what. We're not necessarily saying how we make this run on Slash, like what we need to use or anything. This is just the endpoint that it's going to be served at. What about how? What are the non-functional requirements I'm giving you? Heroku deployment. So I'm saying you have to deploy this on Heroku. This is the tool, the technology that you need to use in order to do that. What else? Markdown format. Yeah, so that's documentation. I'm saying you need to have this specific documentation. Here's how you're going to do it. Version control. I'm saying you need to use version control first of all. So that's kind of a technology or like a process you need to use. And then it has to be in this certain repo, things like that. Other examples, I'm basically defining your tech stack here. I'm saying that you need to run your backend server in Flask, front end with React, things like that. So that should be pretty straightforward, the what versus the how. You guys are going to be defining both, more or less. I'm not giving any hard requirements on technologies that you have to use in Project 3. I am mainly just saying that I'm going to recommend things that you should use based on what you've used so far in the class. Another example of a non-functional requirement I am giving you deadlines here. So I'm giving you commercial constraints by saying you need to have it done in this time. I'm also enforcing that you do this on your own. So you're a team of one engineer that has to do this. And those I'm going to be giving you again in this project. Cool. Okay, so first two steps we've talked about. Inception is kind of defining the process. Elicitation is gathering all of the different constraints and requirements we have. The third step is called analysis, where we're basically going to, once we have, let's say, this big list of constraints and requirements that we've written up and brainstormed, we want to somehow, there's going to be inconsistencies in our requirements, and we want to kind of smooth those out, resolve any conflicts between them so that we can have a very consistent set of requirements that we need. So examples of this could be, let's say you have one user who is saying that they want a text-only app. They just have to text like, I want groceries at this address and these items. That'll be easier for them. You have another user that says they prefer downloading an app in the App Store using like a proper UI. Well, probably given your constraints, it's like 4 weeks and 4 engineers, you're not going to be able to do both. So you need to resolve this inconsistency, this conflict, and decide which path to take and kind of basically talk to your stakeholders about that to make sure that's okay. So if you're going one way versus the other, you would probably want, first of all, enough users that agree with that way, as well as making sure that it fits within your timeline. And once you've kind of taken this big list of possible requirements and basically prioritized it down, resolved some things within it, now it's time to actually document this and write this up. So this is step 4. And this is when we actually write up our specifications in some format. So there are many different ways of writing up specifications. Different companies are going to use different ways. You could have a very informal, like just like a paragraph and a simple diagram. This is what it's going to look like. You could have a whole book of specifications. These are all the different things that this product should be able to do. So mine was just a few pages long, but it was still pretty in-depth. This is a process, though. It's very time-consuming to write. It's also very time-consuming to read, which is why you're probably going to see oftentimes specifications aren't written as much as they really should be. So I know on my team, we are a younger team, like had probably been only established for like 3-4 years, but we were so used to kind of moving fast and not really needing this planning phase that we weren't using specs at all. So the product manager would kind of just come to me and be like, here's what I'm envisioning, just like 2 sentences. The designer would try to come up with a design based on that, and then I would try to implement. But obviously there was just a ton of mismatch between what all of our expectations were, because our product manager didn't actually write down any kind of very clear specs for us to use and kind of be the source of truth that we're all working with. So you definitely want to do this in a group of 4, which is why I'm requiring it. You are all going to have different ideas of what the end product is going to look like. And the more specific you are, the more time you put in at the beginning to be specific, the less kind of confusions and arguments you're going to have down the road. And yeah, this comic was just, it's just real because this is what my product manager does as well. Okay, so there's a few ways of writing specs. Usually you're going to see that they're just written in natural language, which is just English in our case. Just writing out a doc with bullets, pretty much what I've been doing for you guys. There's more formal methods, specific like modeling, diagrams, things like that. I'll show you an example of that later, but I'm first going to focus in on natural language. So the benefit of natural language is that this is very universal. So you can pretty much show these specs to anybody, whether it's your product manager, your user, your business kind of manager. They all can understand this. So you're all speaking the same language. They don't need any specific understanding or training in order to know what your specs mean. But natural language, even though it's kind of easier to write often, it also leads to a lot of traps. So there's a lot of ways where you can write bad specs in plain English, because English is just it's a language and it's such an ambiguous language. So you're going to want to make sure you're avoiding these different traps related to like ambiguous terminology, vague terms, such as like quickly. Well, how quickly is your system going to do something? Quickly could be a microsecond or a minute or an hour. It all depends on the context. So you want to make sure that you're aligned on what you're saying there. Same with user-friendly. Another trap you can run into is kind of just like making a requirement or like a given bullet too complicated. So you want to break things down into very kind of like smaller units so that a given requirement is not kind of being bloated up with a lot of different smaller features. And there's other things like you want to use caution when using certain phrases. I don't really think, I'm not going to go into that, but the important one here is you want to make sure you're separating the how and the what. So a bad example would be, you don't want to say, my system is going to use Outlook to send an email confirmation. You're saying, how am I going to send an Outlook, or how am I going to send a confirmation using Outlook? What am I going to do? I'm going to send an email confirmation. The preferred way would be to simply just say the what here. So the system's going to send the customer an email confirmation. And somewhere else, when you're writing out like your implementation details, you could say Outlook is one of the options that I'm going to go with. The benefit here is you focus on the kind of the goal, the result of like what you want to do, without getting lost in the implementation detail and like that non-functional sort of how. The good thing here is that in your specs now, you know that you want to send an email confirmation. Maybe Outlook is not the easiest way once you try using it. Well, you're not kind of restricted in scope, because that you're still going to figure out how you can send an email, and you could find easier methods of doing it. So I want you guys to see now, let's say like project 1, do you see examples of bad specifications that I've written here? So is there anything that is vague or ambiguous or overcomplicated? I'm sure there are. Any guesses? Yeah, John. So with a more user-friendly interface, this is one of those kind of vague terms that I'm using here. What does user-friendly really mean? Me, Andrew, John, we're all going to have completely different ideas of what that really looks like. So maybe I want something that's really simple But maybe John is expecting something that like just like looks cool and like appealing to the eye, things like that. Similarly, your users, if they say, I want a user-friendly app, the user-friendly is going to mean many different things to them as well. So maybe they're younger and they're used to like the look of Instagram, like scrolling through things, that sort of design. You would want to maybe focus more on that side of things. Maybe they don't really care about the kind of the visual design, but they just care about the layout. So they're used to having a top bar as the menu, and that's where they can like click around to see things. So you're going to want to get way more specific than user friendly here. That was something that I should have been better about. You would want to say like here. So how do you avoid that without a design spec? The design spec is going to help a lot there. That's true. You could just say like referring to my design spec below. Another thing you could do though is get specific in terms of using this color palette. So I want to use blue and white as my color palette. You could say I want to have rounded corners. You could say I'm going to use this font or typography, top bar, sidebar. This is like what the layout's going to be. So yeah, I think it'll all come out easier definitely in a design spec. If you don't have that though, then you would want to just kind of list out some key things like typography, color palette, things like that in here itself. And actually in your group proposal, I am going to require you to draw up a mock-up of what the app's going to look like. So that's going to also give you a better idea. What else? Do you see any other examples of like specifications that aren't written in the best way? Why don't we look at the first bullet? Yeah, John. So that's a good one. Not storing the API keys, things like that. I'm combining the how and the what all in the same one. Ideally, I don't want to be talking about this sort of implementation detail here. It'll be clearer if I just focus in one place on the features that this is going to be, like from the user's perspective, and then in another place focusing more on the system and like the implementation. And that's actually what I was getting at here too. This spec is basically combining that I want to be able to click a link that takes me to the lyrics page, but the link is going to be fetched with the Genius API. So you really should just be focusing on the fact that you're taking the user to a lyrics page. There are a ton of APIs that could take you there. And you can list that separately and show like Genius is one, that's like the preferred method. Maybe we'll use Music's match or something like that. That gives you the room where you can say like, oh, the Genius API docs completely suck. Based on this, we're going to have to change our plan and go to like another option. You kind of focus on the goal here that you just want to get lyrics. And this is all because like this may seem really obvious if you're writing the specs for yourself, like, oh, duh, like I could change this up on my own. But when you're working on a team, then not everybody's going to understand what your assumptions are, which is why you need to be as clear, separate concerns out so that there's less ambiguity for other people. Cool. So on the other hand, some good things that you want to do in your specs and like your bullets basically are having complete sentences, kind of focusing having a subject and a predicate. So usually that subject's either going to be your user, so you're talking from what they should be able to do, or your system, which is kind of your software, how it's going to respond or like how it's implemented, that type of thing. I'm not going to get into the English of this just because it's a little bit much. The main thing I want to focus on here, though, is you should think about these sorts of criteria for what makes a good spec. You want each bullet to have a desired end goal or result. So this user should be able to do blank, that type of thing. So you want to be specific, have some goal. You want this goal to be measurable or testable. So when I'm giving you some specs in your app, in your projects 1 and 2, I was making sure that these are things that I can actually test reliably, to make sure that you successfully did X. And that's definitely a key thing. You want to think about how you can make sure that everything you write, you can make sure that you successfully did this at the end of the project. Are there examples here you see, like, what are things that you would want to emulate in my specs when you're writing out yours? What are some good things that I'm doing here? Let's see, like this example. Formatting and bullet points. So bullets definitely allow you to focus in on specifics, and kind of break things down into chunks, which paragraphs don't allow you to do, because then you're blending in multiple requirements and things together. What else? Okay, yeah, the level of exactness. That's good, John. So I think one thing here that I could have written differently is, what if I had said like useful user information and then cut this out? So I could totally see people writing that, just like relevant information or useful information. Well, that's going to be super vague. So you need to make sure you're more exact than that. Every person is kind of going to say, you want to, like, different people on your team are going to have different ideas of like what that information would be. So you do want to make sure that you're listing out the types of information you want to display on your page. So this username, whatever, spectator's username, and all that. I could see this being a little vague, though. You could do much better than this, honestly, and kind of show more, like, let's say, an example such as player X name 1 or something like that. And that gives you a better idea. Otherwise, maybe somebody could just say name 1 without actually labeling the player type. And then that's not actually a good way of showing the names, but that does still satisfy this requirement. Okay. All right. So now I'm going to talk about like generally specification modeling. This isn't going to be too relevant to you in project 3. I'm talking about it mainly because you might be hit with different modeling types at wherever you work and that type of thing. So the goal of having a specific model in how you write your specs is that it can maybe give you better frameworks to map out, let's say, complex apps. So it might make sense for project 1 or project 2 to just list out stuff in bullets. But as the app is growing, let's say that we're talking about a much larger, more complicated app, bullets might not be making sense anymore because it's going to get way too convoluted to really visualize what something is looking like. just from bullets. So that's where kind of modeling types have come in to play. The informal versus formal language models, we're talking about informal. That's what we're going to be doing. And like I was saying earlier, the goal or like the pro of that is that it's going to be better understood by like all the stakeholders, regardless of whether they're technical or not, regardless of what backgrounds they have, whether they understand what your model is going to be. So that's usually why you're going to see it most often in the industry. But on the other hand, it does increase the possibility for ambiguity. Formal language models, they allow you to be a lot more precise. They can also be useful like for a specific audience. So maybe your requirement is only talking about like a backend system software. And for that case, maybe it makes more sense to write it out using like class diagrams or something like that, that developers are going to understand really well. That could be a case. So in that case, something more formal could be useful. There are a couple of different ways of doing this. So informally, we're talking about natural language. Semi-formally, there are these systems like the UML system, Unified Modeling Language, URN, User Requirements Notation. Formally, there's some other ones. So you can literally write like pseudocode or logic that developers might understand better. Here's like UML. So you could actually visualize what your app is going to look like with these sorts of diagrams. So I have my little smiley face user here. Here are the possible actions that they can take from, let's say, the chat room page. And then you can kind of visualize what are the actions or the sub actions that you can take from a given action. So this really helps you picture for like a more complicated app. For each page, what are all the actions you can take? And also what are the dependencies between actions? So you can only book a flight if you're using the chatbot, not if you're like viewing the active users. So this can help you kind of map out the flow of your app. Again, you're not required to do this in Project 3, but just showing you so you have other ideas. Any questions? Okay. All right, so let's move to step 5 then. We're almost there. I know it's a lot of material. So step 5, once you've kind of written up your specifications, you want to be validating and like verifying that the specs you wrote up are, one, kind of we're building the right product that the stakeholders want, and two, kind of making sure that we're building this product in the right manner. So our system kind of design the right design. So you should really be verifying and validating kind of at every stage of the requirements process, as well as like the software development process. This, in general, your requirements are always going to be changing because life happens, your stakeholders might change things for different reasons. So you kind of want to be always checking in order to adapt to them. Specifically, when we want to verify, we're thinking questions of like, have we made sure that we got all the possible requirements from all the possible stakeholders and users? Or is there somebody we're forgetting? So is there an important group that we haven't focused on? If we talk about like our grocery delivery app, if our market research is showing that it's mainly going to be used by elderly people, but our user groups that we've been interviewing have been all over the age spectrum, then you want to make sure that you fix that and focus in on your specific user group. Also, you want to kind of just check the language of your specs. So have you actually made sure that you don't leave room for ambiguity throughout in your language? Are things as precise as possible? You also want to make sure there's no conflicts or like inconsistencies still remaining. Maybe you've said that uh, you're going to be doing this in 4 weeks, but the scope of it is way too large. So somebody's going to hopefully review it and tell you that, and you can verify that. So yeah, more specifically, if we're talking about validation on like the user side, you want to make sure that what you've kind of written out is what the user is expecting. So let's say that the user said, I want this type of app with this type of feature. You run back to your group, write up that feature. Maybe something was lost in translation, and you want to kind of confirm with them after you've written the specs that this is what they were actually expecting. Maybe they just said it wrong when you were interviewing them, or maybe they changed their mind. So there's a lot of reasons for that. You also want to make sure like just the kind of milestones and everything you've been listing out are covering everything that you expect to make. So you're going to have your end goal, but maybe you've completely forgotten to allocate time for that in your sprint. So you want to make sure you're doing that. And then on the system side, you kind of want to make sure similarly that you are fitting within your constraints correctly, time-wise, things like that. And that your kind of system implementation is going to be able to successfully get you the features you want. So if you want a user to be able to favorite their grocery stores, but you haven't actually written anything about a database, then there's a clear inconsistency there. And yeah, verification, validation, you really want to do that, especially in the very first stage. If you don't do that, and you kind of just keep going with your requirements, then you're going to run into issues down the line. So as I was saying kind of at the beginning, the cost of fixing issues later on in your phase, in your software development cycle gets higher and higher as you get farther and farther into the process. So going backwards would be really expensive. If you're making sure you're doing a lot of validation, you're actually going to get rid of a bunch of potential issues that you would have run into later down the line. So that's why there should definitely be an emphasis on this at the beginning. And it's going to just save you time and pain in the future. How do you actually like verify and validate? For you guys, the main way is simply just going to be like checking through. So you want to logically read through your requirements and make sure that you are not missing out on things. So similar to just editing a paper or doing spell check and things, you want to check on your requirements. The other thing that you'll probably be doing is a team review. So the benefit of having an industry mentor is they can act as a validator. When they see your specs, when they see your plan for the next week, they can basically tell you if you're missing something, if they can also, if they realize it too. So that's why having another set of eyeballs that look at it is going to be really useful. Similar to like me and the TAs creating your proposal, you'll get some review out of that. So you'll mainly be doing a combination of simple checking as well as reviewing. There are other things though that are possible. So prototyping is one. Sometimes you'll see people just want to like make sure that this is making sense and like do a sanity check by like making up a really short, quick version of your app and seeing that that works before you dive in deeper and really invest the time. You're not going to have time to do that, but that's just like something that people do if they have more time. Another thing is like test design. So sometimes if you're doing test-driven development, you want to first create your tests and be like, my software is going to be able to satisfy these tests, and that's how I'm going to know that I did it correctly. So these can be really important validator as you start coding. And then the final step now. So final step is management. And this is kind of about dealing with changing requirements as you go through the flow and you're implementing. So changing requirements is as certain as death and taxes. It's gonna happen. That's just life. You really need to make sure though that you're addressing the changes as they're happening as early as possible and updating your specs accordingly. So you probably remember from my specs, I've had to change them pretty often. So in milestone 3, I realized that from my stakeholders, which are you guys, the students, I'm seeing that working on 3 tests per like mocking and unmocking is asking for a lot if you have really simple logic on your Python side. So that's why I address those changes by reducing that requirement. Or maybe I realized that certain errors from the linter are expected and it would be unfair or like not feasible to ask to change those. So there's another example of needing to change the specs accordingly. And that's something you'll definitely be doing throughout the process. What the group proposal that you come up with next week is not going to, it's most definitely not going to be the same group proposal you end up with at the end of the project, because you're going to run into all sorts of issues that you didn't expect. And yeah, just in like the real world, there are tons of reasons for these changing specs or requirements. Customers could just change their minds. That happens often. You know, we're fickle in like what we want and what we think is cool or useful. So you kind of got to be evolving with the customer as you're making something. Cost problems, maybe one of your engineers is going to drop out of the group. Well, you need to know how to update that and adapt to that. Priorities may change. Strategic goals from like up top may change. So that could be in my case, maybe I'm changing the specs later on and you got to adapt to that. And then less relevant is laws and regulations could change. So I know like at Facebook last year, after the big like settlement with the government and the FTC, we had to spend a lot of time and shift our priorities on pretty much all teams across the board in order to focus in on privacy, kind of make sure that our whatever data we're storing and things like that, we're not going against our rules because of all the crazy shit that Facebook does. So we definitely had to change our priorities and our plans and our specs basically according to that. And that's according to outside factors like laws. All right, so that was a ton of talking. You guys are not going to need to do like all 6 of these steps like so formally in the week that you're kind of figuring out your proposal, but I'm hoping that this gives you an idea of the right questions to be asking and the right methods of like writing out your specification. So like avoiding vagueness, doing multiple checks, things like that. So yeah, are there any questions about this whole process in general? Okay, guys. That is actually it then for today. No homework for Friday. I'm going to release the midterm on Friday though, and that'll be due by next Tuesday. Start thinking about project 3 ideas in general so that you can come to your group with things that you might want to pitch. So start thinking about that, different like possible feasible things within 4 weeks. I'm going to go over the specs though on Friday, but there really is no limitation apart from having a database having a client, having a server, having testing, that sort of thing. And next class, we're going to dive in deeper into how to write these sorts of user stories that you're going to need to write in your group proposal. But that is it. I am going to stay back for another 10 minutes. So if anybody had to ask me any questions, I'll be here. Otherwise, have a good few days and I'll see you on Friday. Okay. Have a good day. Bye, Tyler. Thanks, Jaya. Take care. Bye, Mervin. Thanks, Albert. Bye. David, that's okay if you're feeling sick. Go ahead and reschedule on the Calendly event. Same link. Hope you feel better.